Hi, everyone. Welcome to the second class for OffChain Code Beginner Web3. This is Ben Shadroff again, and I'll be helping lead this class on a beginner session to learn more about Ethereum and how to do development using for Web3. Just a quick recap. I've been here in Guangzhou, China for the past 3.5 years. Previously, have been working in large systems integrator companies and currently working for an international bank. Everything that I'm showing here today is just for hobby purposes only and for education, not financial advice, not representing any employer. But if you want to get in touch with me, in the lower left-hand corner is my WeChat, which you can connect with me. In the lower right-hand corner is my Ethereum address if you want to scan and certainly leave any tips. And I'm always happy to help out anybody to reach me via any of the contact methods I had. So what we've covered in the last lesson is we went through the console.log, which allowed us to write out to the console some information, usually used for debugging or other purposes. We also covered how to do comments in JavaScript. This was, again, being able to do a / or a /*. We'll talk about that in a second. We did a little bit on numbers, arithmetic operators, objects, methods, and properties. So if you didn't go through lesson 1, Lesson 2 is going to build a bit upon that, so I would recommend you to go back and watch Lesson 1 and go through the Code Academy examples for the JavaScript first. But in this lesson, we're going to jump off of JavaScript a bit. We're going to come back to it. We're going to talk a little bit about Ethereum. First, a broad introduction, very, very high level of what is Ethereum. And then we're going to dive into metamask, which is our Web3 plugin for interacting with the Ethereum blockchain. We're then going to go back and start to cover lesson 2. Now, I don't expect we're going to go through all the examples in lesson 2 for Code Academy around variables, but that's going to be your homework to take away after the end of this class. Well, that's one slide too many. Ethereum. Now, there is a lot to cover with Ethereum. This is as high level as I could possibly make it into a single brief slide. But if you're going to take away some things around Ethereum, it's very helpful to know these names. Vitalik Buterin and Gavin Wood, as well as many others, were the notable co-founders of the Ethereum blockchain. If you've not read the white paper, which came out, it seems so not that long ago, but it's been since 2013 now, that white paper still is worth a read. And as additional exercise, I would highly recommend you to go out to that web address and read the white paper. Not all white papers are this good. This is one of the best. And it really was groundbreaking at its time. And even reading it, as I just did about an hour and a half ago, it's amazing just how well it's held up. The vision in it is just incredible. So definitely take some time to read it and try to understand as much as you can. It is a bit technical, as what some white papers are, but don't get too overwhelmed necessarily in the technicalities of it. Look more for some of the practical applications that they were trying to highlight they would cover. And then you can now look back and see a lot of it of what they proposed is actually now live. So this chain was launched subsequently 2 years later in 2015. And a number of the things that they were building, you could identify as perhaps Bitcoin challenges. Where Bitcoin definitely came out first, it was groundbreaking, and it really proved out how to do a blockchain in general for a distributed hash, being able to have proof of work, etc. But some of the challenges that around it were, as Bitcoin gained adoption, more and more people wanted to participate in the proof of work algorithm. This is called mining. Mining first started off by using just your generic computer called a CPU processor. And then progressively, as more and more people joined on in, the race began. Bitcoin itself actually doesn't need a lot of processing power. Contrary to popular belief, everybody says, oh, Bitcoin uses a lot of electricity. People use a lot of electricity to mine, but it's actually not necessary. The algorithm is designed so that the more people that join on in, the harder the algorithm becomes. And so if less people were to be doing mining, the algorithm would actually get easier. Ethereum realized this, said, well, it's just going to be an arms race. More people joining on in is just going to mean more and more processing power. And to kind of put an upper bound on it, they made something called Asic Resistance. This was an algorithm that's designed to then make it prohibitively expensive to use really, really expensive, hard to purchase processing power called ASIC chips, application-specific ICs. These are what are used for Bitcoin mining. If you've ever looked at a Bitcoin miner, go Google it. You can see the images of it. You'll realize pretty quickly it doesn't look like any normal server. It looks kind of unique. It has a really big honking amount of fans on it. And the chips themselves are, well, they're application specific. They can only do one thing, mine Bitcoin. Ethereum would try to stave off this, not quite successfully, but successful enough to say it'll only support up to GPU, graphics processors. And that's helped in many ways make more decentralization, because just about everybody has a GPU or has enough money to go and purchase a GPU. And that allowed more people to participate in the blockchain proof of work and therefore help achieve more decentralization. We're not going to go into what Merkle trees are, but if you're really interested in the cryptography aspects of how the blockchain actually provably works, I highly recommend checking out the Wikipedia article, and you can get overwhelmed easily, but it's really interesting type stuff. And I think this is, again, some of the more groundbreaking work that happened, not just to say that Ethereum was first, but they really did break a lot of ground in proving out some of these concepts. The main thing I want you to take away is the vision. There were notions of decentralized applications before Ethereum, but I would say that Ethereum was the first to really go and prove a wide scale type adoption of it and put a lot of thought into how to achieve it. They laid out that they wanted to do financial dApps as an obvious choice because, well, a token can really help solve financial transactions, but they're also semi-financial, like reward systems, like for achievements, and then even governance type tokens, as we now call the Decentralized Autonomous Organization, a DAO. They put this in their original white paper back in 2013. And I think that's what's so incredible about the Ethereum ecosystem, was that their vision was not only spot on, but they also had great execution to achieve it. So a little bit of computer science here, Turing completeness. So you may have heard of Turing. He's the person who really came about with this idea of modern computers. I'm not going to go into how they all worked, but the idea is that instead of just keeping a ledger of who has what token, they wanted a complete language to be able to then execute in a decentralized way where anybody could participate and arrive at the same answer. Now, normally, when we put an application out to the cloud, you're putting it out to a centralized server. Usually the code is not even shared. And really then only one, or maybe the machines that you're giving access to, would have access to go and complete it. And there's really not much built in to verify whether all the machines agree. The Ethereum blockchain is instead turning that around to say, let anybody go and participate in executing the language, and it's going to verify whether or not we have the same answer. And as well, in order to prevent somebody from putting an application in that just completely overwhelms the network, we're going to introduce this concept of gas. Just like gas goes into your car, it's the same analogy. When your car runs out of gas, well, it stops driving. And the same concept applies to any sort of transaction on the Ethereum blockchain. You need to provide gas for everybody who's participating to then know how long should they participate for. Again, getting into the computer science of this, when you have a Turing complete machine, it doesn't mean that it's ever going to finish. And it may get a problem where there is no answer. And therefore, we have to have the concept of gas to say, when do we give up? When do we just say, well, not enough money to go solve this problem, time to just give up and move on? Well, that was solved effectively with gas. And in order to achieve that, they laid out a complete Turing completeness that would then describe how expensive each operation would be. Again, we're not going to go into exactly how all this works, but these were some really incredible concepts. And what it's led to is a vision that was able to be executed, one that you really can build just about any decentralized application you want. So moving into then MetaMask. MetaMask came later. It was created by consensus, and you can think of it as a Web3 plugin. It itself resides inside your browser. It doesn't have any part of the Ethereum blockchain itself natively, but it knows how to speak to the decentralized network to then broadcast your message on out to anybody who's listening to say, hey, Ben wants to go do this transaction. Let's make sure everybody else knows about it. And should you provide enough gas, it should be then in theory picked up by the miners, processed, and added to the blockchain. Again, we're not going to go into exactly how blockchains work. Frankly, many people don't know how most systems work, and they work just fine. If you want to dive deeper into this, many YouTube videos to go look into it. We're going to keep it pretty high level and just really focus on the functional aspects of how can we use MetaMask to work with an Ethereum blockchain. So before this class, I did try to ask everybody to give it a shot. I didn't provide any instructions on how to install MetaMask, and that I think worked well for some, and for others, well, it's always challenging to install any piece of software. And I think this is one of the hardest parts. So let's actually go through it together. You'll see that today I'm using Brave on Mac OS. It's going to look slightly differently to you, depending on which browser you're using. I do tend to recommend try Brave or any Chrome browser or Firefox. These tend to be the most widely compatible, although MetaMask does support many browsers now. Now, if you already have it installed, you don't need to do anything else. But as you can see, I have it already installed, and you're going to be looking for your extensions bar in your browser. Now, in my case, I already have it installed, and if I click on it, it'll pop up, and it'll show me information about it. Now, for everybody that doesn't have it yet, I'm going to pretend we're going to get rid of it. Don't do this if you already have it installed, but you can follow along if you want. So I'm going to remove it from Brave just to show what it would be like to reinstall it. So now it's gone. Cool. To get it back, what you'll want to do is go to the Chrome store, and you're going to search for either MetaMask here. And this is a good way to make sure that you're on the Chrome store. The other way, which is perfectly fine, is to go to metamask.io/download.html and click the download button. Just make sure that you're absolutely positive you're on the correct address. There are scams out there. I would hate to see anybody not check this and accidentally go to a scam website. Make sure it's metamask.io. And then you can click on install MetaMask for whatever browser you wish. I would avoid doing iOS or Android at this point. You really should be using a desktop-based browser for the examples. Again, that's going to take you on into the Chrome Web Store. And then if you already have it installed, it's going to say remove. But in my case, I've already removed it. So now I'm going to add it to Brave. It's then going to give you a prompt to say, are you sure? And I click on add extension. It's going to check it, download it, and then proceed to install it. Okay. Great. MetaMask has been added to Brave. And at this point, it should pop on up. And you'll get this cute little Firefox, well, not Firefox, MetaMask Fox that's looking at my cursor. That's a good indication that you have successfully installed MetaMask. You'll notice that my Fox icon has disappeared from my extensions bar. If you're missing it, depending on which version of Chrome or Brave you're using, there are different ways to get it back. In my case, I'm going to click on this puzzle icon. And then here it'll say MetaMask, and I need to pin it. At that point, it's going to show up. If you don't see it here, and we had some students having difficulties, you may need to go into some of the menu systems. You need to find where your extensions are for Chrome. And again, you're going to want to make sure that somewhere within this list, you see the word MetaMask. If it's not enabled, make sure you click the button to show that it's enabled and make sure that you're seeing it ideally in your browser bar for extensions. Okay, so at this point, we have it installed, but we haven't configured it. Again, if you click on it, the first thing it's going to do is pop up to say get started. You're going to click on get started. If you're new to MetaMask, you're either going to have to import a wallet, which if you're new, you probably do not have a wallet. If you already have a wallet, yes, you can import it. But for most students, I'm going to say go ahead and click on create a wallet. Now, here they're going to ask, do you want to send some information to MetaMask regarding collecting information? It's entirely up to you. They are reasonably reliable and they have good privacy policies. If you don't feel comfortable, just click no thanks. You're then going to enter in a password. This password, I do feel comfortable storing in a password manager, or you can put it somewhere offline to keep it, but just make sure that you don't forget it. You will need it to get back in. Once you click on create, it's then going to create you a wallet. Now, this is a very nice video that you can watch in your own time, but I'm going to skip past it and click next. And in my case, yes, I do know that I'm about to reveal the secret words. Unfortunately, if you don't do this, it'll keep prompting a warning. So I am not going to use this address ever again, but let's go ahead and do it. These are called seed words. Seed, like a seed from a tree. Seed words are how you can recover your MetaMask. And if there's one thing you take away from this class, please back up these seed words. They're really, really critical. The same seed words for the mainnet are identical to the seed words for any testnet or any other Ethereum compatible blockchain. If you lose your computer, there is no way necessarily, unless you made a backup of these seed words, to get back all of the assets you're putting into this wallet. Just like if you dropped your wallet outside, if you don't have some phone number in there to make sure that you can find it again, well, it's gone for good. So please take the time and write these seed words down offline. Do not put them into your inbox. Do not put them into a password manager. Don't put them into a text file on your computer. All of these are very common hacks where if a hacker gains access to your password manager, your inbox, or your computer, they're going to look for these keywords. And if they find them, I can almost guarantee you will lose your tokens that are stored here. So the only way I recommend is to store them on a piece of paper, or get a piece of metal and inscribe them on them. Or if you're planning on putting a significant amount of worthwhile tokens on them, get a hardware manager. A Ledger or a Trezor are both great, or there are many others, but things to look into. So in order to not get an annoying message, I'm going to type in these in order so that it stops prompting me about the backup. And again, this is a worthwhile activity to remind everybody that this is really important and you should never share it like I'm doing right now. Okay, they're in order. I click confirm, and congratulations, we're all done. Great. You can also get the mobile app too, and you can actually then synchronize your tokens with your mobile app too. There's a bunch of other stuff you can do, yada, yada, yada. Take your time, go look at it. Okay, as you can see, I have nothing in this wallet, but I'm actually today going to be using a hardware wallet. So just a quick example on that. I'll come on in, and if you have a hardware wallet, it's quite simple. If it's supported in MetaMask, you're going to click on this circle icon, and it allows you to see what accounts you have connected to MetaMask. There's the account that we just created. If you wanted to, you can actually create multiple accounts. So if you're feeling that you don't want to have all of your assets into a single wallet, you could go create it, but I tend to just recommend stick with one for the time being. I'm going to go ahead and connect my hardware wallet. I have a Trezor. The hardware wallet is a little better in that, just like we saw those private seed words that we're not supposed to share, in fact, with the hardware wallet, we never see those on our computer. It's permanently stored within the hardware itself. And you can back that up still, but the idea is that you don't need to then make sure you have that written down anywhere that you could accidentally spill it. And just like that, I'll click a button on my hardware wallet to confirm that I'm connecting, and then I wish to do so. I'll link up my wallet, I'll unlock it, and voila, I am now connected to my hardware wallet. Again, if you want to switch wallets, it's just a matter of clicking these circles. You could switch back and forth between a hardware and a software wallet, and you'll see that the hardware wallet is clearly indicated by hardware. You'll also notice that sometimes you're seeing MetaMask in a full browser window. I prefer actually to just kind of use it off of the extensions by clicking it, and it gives you the exact same information in a nice tight little package here. So today we're not going to be interacting with the Ethereum mainnet. Instead, I provided people that have shared their public key some Coven test network. So Ethereum mainnet is, the real thing. That's when you send that money that has real value. These other test networks are for developers, and they're meant, just as they sound, for testing. We're going to use Coven because it'll allow us to quickly be able to stand up Ethereum-like decentralized applications without any of the cost. In fact, if you're doing real development, I don't recommend using a test network that's public. There are tools that you can use locally where you can host a simulated network and you can develop much faster and easier. Things like Ganache are tools that we normally would use. But that adds complexity. We're not going to get into that in today's class. We're going to keep it simple and just stick with the Coven test network. Go ahead and click on Coven. At this point, you just saw a bunch of my numbers change. It's now saying I only have 0.3114. If I switch back, you'll see that it's more. So again, different networks have a different notion of how much ETH I have. In the test network, it's worthless. These ETH are not worth anything. And I'll show you in just a bit on how to get more. But the thing that's important is my public key did not change. So if you're still confused where to find your public key, it's right here. In fact, if you click on this, it'll copy it to the clipboard, and then you can go ahead and paste it somewhere else. This public key is then a representation of my private key in a way that I can freely share with anybody else, and they can read all the assets I have in my wallet and all the past history I've done, but they have no way of actually signing a transaction, meaning they can't go take my money. They can't go and impersonate me. And this is the beauty of cryptography. Public and private key cryptography allows us to be able to have trust on the internet. Even though we can't see each other, because of the fact of how this cryptography works, it allows me to say, oh, because I see this key was owned by this other person and it must have been signed, therefore I can trust that other person. We're not going to get into how public and private key cryptography works, but I think if you wanted to take some YouTube video lessons on it, it's very interesting to go look up on it. So I just saw somebody in class post their public key. This is a good opportunity. Let's go use them as an example. What we're going to do is go try to send a transaction. It'll let me. Too many documents open. Too many tabs, too many things. All right, where are we? WeChat, come on, there we are. Okay, so we had a few people, Alex and Philip, both posted their public keys. Let's go take Alex first and show an example of how to send a transaction. And if you want, yeah, thanks, Alex. If you want, you guys can try it too, but I would encourage you, don't send all your money. You're gonna need some of it later. All right, man, my browser is not deciding to come back up, so we're gonna try to switch around here. All right, there it is. So again, click on the Fox icon in the upper right-hand corner for your extensions. And to send a transaction, it's just a matter of clicking the send button. It's then going to prompt you, where do you want to send it? And you can either search, provide a public address, meaning it's starting with 0.x, or ENS, Ethereum name service. We're going to send it to Alex because he provided us his public address. Make sure when you're sending a transaction, you're on the right network. Nothing worse than for thinking that you're on a test network and then giving Alex a very nice gift of some real ETH. So in the amount, you're going to provide how much you want to send them. I'm going to send them a very small amount, 0.01. Since some of you received 0.01, perhaps consider sending them 0.01, something very, very, very small. In fact, if I recall correctly, you could do something like 10 to the negative 18th. So it's a lot of zeros. Feel free to send them practically nothing. No offense, Alex, but you're not worth it. All right, so 0.01. And then what we're seeing here is the gas price and the gas limit. The gas limit is then showing us how much is this transaction going to cost. And you're going to see this 21,000 an awful lot. In fact, when sending an Ethereum token, it always will be 21,000. Now, different smart contracts will then get computed to be different. And the gas price is then a multiple of this. Right now, the gas price is 1.000. Well, it's practically 1. I think there's a 7 at the very end of this, indicating that it's slightly above 1 gwei. A gwei is 10 to the negative 18th ETH, aka it's practically nothing on the current testnet. And what's going to happen is the price times the limit is then going to be effectively how many gwei you're going to spend to send this ETH. Now, in fact, you can change the gas price, and we'll talk about that next. But for the time being, assume the gas price is correct and go ahead and click next. At this point, it's going to provide you a confirmation about your sending ETH 0.01. It's going to give you an estimated gas fee. Huh? I thought we just gave it the gas fee. No. In fact, it's only an estimate, meaning that that's the maximum that we're going to do, but it could be less than that. And this is helpful to then cap your amount. So it's allowing us to see we're not just sending 0.01. The maximum that we could potentially be giving away is 0.01 plus the 21,000 times 1.0007 and a few other zeros after that. So that's the maximum that we'll be spending. This is very, very important. Whenever you send a transaction, really pay attention to this max amount. Because in theory, if the network is very, very heavily used at that time, you might be paying a lot. And it's important to know that. Go ahead and click confirm. Now, in this case, because I'm using a hardware wallet, my screen is going to look slightly different than yours. You can't see my hardware wallet at this point, but it's now prompting me to say, are you sure you want to send ETH to this address? I click confirm. And then it's double checking to say, did you really want to send this much, paying this much for gas? And I, again, push confirm. At that point, it's then confirmed. If you were using a software wallet, the process would be a lot simpler. It would just basically go through. Okay. I click on my MetaMask again. You'll see that it's sending. In fact, it's pending. So we now have to wait. Oh, Alex says he's received it, but MetaMask says it hasn't even sent. What happened? Well, it's a decentralized network. There isn't necessarily going to be immediate confirmations on either side. And until enough parties agree, you may see a little bit of a lapse. But the good news is Alex did receive it, and it has now been sent. If I click on it, you can see that from my address, 0x06f2 and a bunch of other numbers and letters, sent to Alex's address this information. Nonce means what was the number of the transaction? It means that I've done 63 successful transactions. Well, it doesn't even need to be successful. 63 transactions previously. And then it's showing that I've decremented, meaning I've given away 0.01 ETH for this transaction. The gas limit that I provided was 21,000. And the gas used was, in fact, 21,000 at a gas price of practically 1. So just like they predicted, my max was pretty much hit. Now, in the case of a testnet, the gas is pretty cheap. So normally this gas price is going to be much, much higher on the real Ethereum network. I've seen it over 1,000, and then it's very painful. But normally you'll see transactions of maybe gas prices in the 30 to 80 range. And it's important to keep track of this because it's a multiple. It's a multiple of the gas price times the gas used in units, and that's going to then show you how much potentially you're going to be spending. The thing that I really wanted to show then is Etherscan. If you click on this arrow icon, it's going to take you to a website. It's important to remember Etherscan is not the blockchain. It is just a read-only view, effectively, of what it has found on the blockchain. In practice, anybody could actually run the blockchain themselves on their computer, and it would take a lot of storage. And therefore, Etherscan has decided to provide a very nice public service to allow anybody to easily search the blockchain. Whereas if you were running it yourself, it wouldn't necessarily have all these nice bells and whistles to make it easy to search. I really like Etherscan quite a lot. It's a great debugging tool to be able to see exactly what happened. Every time you do a transaction, it's going to be assigned by the blockchain a hash. This is a unique identifier to say this transaction is represented by this very long string. I will say it is a bit confusing because this string looks awfully similar to a from or to a public address, but you'll notice it's a lot longer. And that's allowing many transactions to be identified uniquely. It's very important to see the success status. When you first submit the transaction, you'll notice it goes into a pending state, meaning nobody yet has picked it up and it has not actually gone through. When you're dealing with a distributed database, it's important to remember that until you have multiple confirmations, you really can't trust it. So at this point, 30 blocks have now confirmed that this transaction on this block has been successful. And that means after 30 blocks were mined after that, it's cryptographically impossible for this to have been false, or there would have been what's called a fork. It means that some people on the blockchain disagreed. In this case, if you wait a few blocks, like even 2 or 3 or 4, you can be relatively certain that you're dealing with a very valid transaction. And if you want absolute certainty, like maybe an exchange once, you'll notice that many times when you send tokens to a centralized party, they may require 10 block confirmations before they truly trust it. The timestamp allows us to see exactly when it happened. And again, I sent it to Alex, and the same information we were seeing in MetaMask can be shown here. But there's a bunch of more information to really dig into the gorp of exactly what happened here. You can see that we spent 7 Wei as the base fee on the gas. We're going to use Etherscan quite a bit as we actually start to interact with smart contracts, because it provides a lot of debugging tools for being able to see exactly how a smart contract works. But for a simple transaction like this, it's pretty straightforward. Person A sends it to person B. One thing that's really useful for this troubleshooting, though, is if you want to go and say, well, how did I get the money to go send to Alex? You can actually click on my address. And what it'll do is take you to then the Etherscan address of my blockchain on Coven, or sorry, my public address on Coven. And you can see all of my past transactions. So really, now you can see what I did to get everybody in the class set up. I was sending 0.1 ETH to lots and lots of people in the class. And if I haven't sent it to you yet, I apologize. I will get it to you later. In fact, at some points I was sending 0.05, but then a lot of people started asking for ETH and I started running out. So that brings me to another point. What happens if you need more test ETH? Well, on a testnet, it's quite nice. You can go and freely request more. Although, please don't abuse this. This is meant for developers. Don't come in here and start requesting lots and lots of test ETH unless you have a real need for it. But if you go to faucets.chain.link/Coven, you can put in your public address, specify the Coven testnet, and then request 0.1 test ETH. Prove that you're not a robot. I'm not very good at these. And then click send request. And a few seconds later, the transaction should be submitted, and then you should be able to receive some more test ETH. I encourage everybody to give this a shot. It's possible, that especially if I only sent you 0.01 ETH, that you may run out at some point. Please go ahead and try running faucets.chain.link/Coven. And then again, you'll get this confirmation. You can even click it. It's going to take you back to Etherscan. And just like we saw before, it is now showing us exactly who sent to me the 0.1 ETH. And similarly, if I go into my MetaMask, after a few seconds, you'll see the receive. I've received 0.1 ETH. There it is. Cool. Okay. That's a lot for day one on MetaMask. We're still covering it at a very high level. But the thing I wanted to show you about this is an introduction to Ethereum, how to send a very basic transaction. And now we're going to build upon that idea. What this plugin allows us to do is interact from a web page with the Ethereum blockchain. And you need that because, in fact, it's not possible without this plugin to be able to do so, because we need something to manage that private key. We need to be able to say where that seed phrase is to be able to sign the transactions. And that's really what MetaMask is securely allowing us to do. We're not sharing our private key or our seed phrase with any website. Instead, we're keeping it all within our local browser. If I throw this computer away, it won't have any of my information, anymore. If I destroy it, it's gone. My hardware wallet would be the only thing that has it. So we need this plugin to be able to interact with websites. Once you have it, though, websites can then do a lot of things. So as an example, I'm going to go to an example application that is on the Kovan testnet, openleverage.finance. If I click on testnet, what you'll see in the upper right-hand corner is a very common way for decentralized applications to interact with a blockchain. In this case, it's saying it's a testnet for Kovan, which is good because I've already turned on my MetaMask and made sure that I'm on the Kovan testnet. Normally, what it'll do next is then say, connect your wallet. Now, there are now many Web3 compatible wallets, which is great. MetaMask, I do think, was the first. Correct me if I'm wrong, but I'm pretty sure it was the first. And it is by far, as best as I can tell, the most widely used. But there are others you can go explore in your own time. Go ahead and click on MetaMask. And what this web page is now doing is it's notifying the plugin in my browser that I am authorizing MetaMask to interact with this DApp, or decentralized application. You need to then confirm which of your various wallets you want to give access to. I'm going to go ahead and select my Trezor and then click connect. And before I click connect, this is actually important. Make sure you look at what you're giving access to. All I'm giving access to in this case is to view the addresses of my permitted accounts, which is required. Like, there's no way to disable that. You have to at least say, this is my MetaMask public key. But make sure you look at these warnings carefully. If you're using something that isn't trustworthy, you might be giving away more than you realize, and you should take some pause and really try to understand what you're doing. In this case, I'm quite certain that I'm allowed to share my public key. Cool. Now that I've authorized it, this decentralized app is able to read information from my wallet. It's saying now that I have 0.4 ETH roughly in this wallet. And that's great. This is now showing how an application that is able to then interact with a decentralized Web3 plugin. And throughout the rest of this course, that's what we're aiming to achieve, is build websites like this that use JavaScript to then interact with the plugin, MetaMask, to be able to do this type of information. Now, to get to that point takes some more development work. So we're not ready to just go start building dApps yet, but I hope that gives an idea of basics of how to use Ethereum, basics of how to use MetaMask, and the vision of what we're trying to achieve, which is integrating a web page using JavaScript into MetaMask to then interact with the blockchain. All right, let's go ahead and switch back to learning more about JavaScript. We need to build up some more fundamentals before we can actually go and build a dApp. Where we last left off was on lesson 1 in Code Academy. Go ahead and switch back to Code Academy. And if you've not gotten to the completion, you do need to complete lesson 1 before they're going to let you go on. In this case, it's going to quickly review at the very end of lesson 1. What did we learn? And just a quick recap. We did things like console log, hello world, which when you run it, this object, which has this method, hello, which passes these arguments, hello world, will then print out the string hello world. We can also do things with arithmetic. To be able to, instead of using a string, we could do 1 + 1. And as expected, it would actually do the arithmetic operation to do an addition. And if you wanted, you could do even bad things like 1 divided by 0, and it would do very weird things like print out affinity, because you can't take a number and divide it by 0. So again, these are objects with methods, and some objects also have properties. Like we could say hello is a string. That is also having a property called, all strings have the property to uppercase. And if we run this, watch what happens. Nothing. Why? Because we didn't print it out. Remember, you have to do console.log and pass in if you want to print it, you better put it in the console log, otherwise it won't show up here. And as expected, the string is now uppercase. And then we can also access other properties to see those things. And there's a number of other properties that they had to explore, like the math built-in objects to be able to do many other operations. All right, that's enough on lesson 1. Let's go to the next lesson, variables. Now in the next 20 minutes, we're not going to likely complete this, but we'll make good headway into it. We have to get through a few more lessons of JavaScript before we can start marrying up what you've learned in JavaScript to then the Ethereum blockchain. So I promise you it's coming, but we do need to make sure that you understand some basics here. In this case, variables are a way of being able to store some data that you can then use later. So var, short for variable, is a JavaScript keyword that creates or declares a new variable. In this case, they've made a variable called my_name. You'll see that many times programmers will put lowercase and then uppercase. There is no necessarily right way to do it, but this is just one way called camel case, where you can then make sure that it's very easy to read, my_name, and Arya is the name. You'll see that in order to set the variable to something, you need to use the equal sign. So just like we can say 1 equals 1, we can now say this variable equals this string. Let's go on down and see the exercise. So declare a variable named favorite food using the var keyword and assign it to the string pizza. All right, so again, we're going to start with the var keyword. All variables must be declared using var. We're then going to use the exact name that they provided, favorite food with a capital F on the second for food. And then we're going to set it equal to pizza. This is a string, but you could set it to many other things. It doesn't have to necessarily be a string, but in order to complete this successfully, we'll do what they say. Pretty easy. Declare a variable named number of slices using the var keyword and assign it the number 8. So as you can see, variables can be taking different types. In this case, the first one, I used a string. In this next example, we're going to give it an integer. Integer is like whole number. Cool, done. Under the number of slices variables, use the console log to print the value saved to favorite food. On the following line, use the console log to print the value saved to the number of slices. All right, go ahead and give this a shot. I'm going to pause for a second. Hopefully you can remember back from the first lesson how to use console log. And then instead of directly putting in what we want to print out, let's now use the variable to then reference what we want to print out. So we can see that by providing the variable, it's just like we provided the word pizza directly on it. And that's a useful concept. And to complete the exercise, we'll do the second one. Remember, variables should not be using any quotation marks. If you accidentally do this, what you'll get is not the variable, but in fact, the name of the variable printed on out. So make sure when you're using variables, there shouldn't be any quotes around them. Okay. And at this point, if anybody's getting stuck, feel free to come off mute and just directly ask me a question. All right, create a variable, let. So as mentioned in the previous exercise, the let keyword was introduced in ES6. This is a newer version of JavaScript. The let keyword signals that the variable can be reassigned a different value. So let's take a look at the example. Let meal equal enchiladas, a Mexican food. So if we console log the meal, what I would expect to see is, of course, enchiladas. What's great about the let variable is it allows us to be able to reassign it to something different. I can now take meal and set it to burrito. And now when I print out console.log meal, I'm going to see burrito. Just as a quick example, if we use var meal and set it to enchiladas, yeah, more or less. Okay, and I did then meal equals burrito. I always find it quite helpful to take some of these examples and break them when you're trying to learn a new concept and see what happens. So in this case, now console log will put out burrito. Let's go ahead and use let. Cool. When using the let and even var is that we declare a variable without assigning the variable a value. In such case, the variable will be automatically initialized with a value of undefined. Let price. In this case, we've not provided any equals. So console.log price will put out undefined. Let's go ahead and try it. Sure enough. And then if we want to, we can then appropriately assign it the right price. And now it does what we expect. It's going to put out 350. Okay. Instructions. Create a let variable called change me and set it equal to the Boolean true. Remember back to lesson 1? We talked about Booleans briefly. These are variables that are either true or false. So in this case, we're going to set it equal to true. Great. Now I'm going to go ahead and change it. So change me. It's going to be now set to false. And it's asking to then console log it on out. Cool. So we're able to take let variables and reassign them to a different value, whether they be an integer, a string, or in this case, a Boolean, and then print them on out with the new value. All right, let's go to the next exercise. So if let variables are ones that you can change, consts are the opposite. You're not allowed to change them. So in this case, is there a question out there? All right. We set my name to Gilberto. Console.log my name will show Gilberto. If I then try to then shape my name, it's actually then. Ooh, interesting. Why would we want to do this? Well, for safety reasons, for one. It allows us to make sure that we don't accidentally go and change something that was really never intended to be changed. Another thing that can be done beyond safety is like enforcement. If we make some code and we are giving it out as a third-party package, sometimes you just don't want other people to tamper with certain things. So it allows us to make sure that that doesn't accidentally happen. So assignment to constant variable is the error. And again, if we were troubleshooting what in the world does this all mean, you can see that something on main.js on line 2 is going horribly wrong. And it's then saying my name, and then it has this little tick mark next to the equals. Ben, that tick mark is saying where the problem is. And they're absolutely right. When you have a constant variable, you can't equal to anything else. It's just not allowed. Otherwise, it's a syntax error. So let's go ahead and do the exercise. We're going to create a const called entree. We're going to set it equal to the enchiladas that we were talking about before. Great. And just to check that you saved the value of enchiladas to entree, log the value of entree to the console. All right. Sure enough, that looks good. And building upon this example, they're now saying, go ahead and try to change that entree. And just like I showed with Gilberto turning into Ben, we're going to see the very same type of error on the third line. Entree cannot equal tacos because it was a const variable. It's not allowed. Okay. Mathematical assignment operators. So now we've got this concept of variables where we can assign integers. So they're now saying let level up equal 10, power level equal 9001, multiply me equal 32, quarter me equal this 1152. Let's see what we're supposed to do here. If we run it as is, what it's doing is it's printing out in these console logs what the current state of each of the variables are. We're now introducing some new mathematical operators. Now, if you've gone to school before, I don't remember in any of my math classes plus equals. We only really use this now in programming. So what in the world is a plus equals or a minus equals or a star equals or a divided equals? These look kind of crazy, but they're actually nice shorthands to be able to do a lot of different mathematical operations. So in the case of let x equal 20, we can then say x minus equals 5. This is the same as saying x is now going to be restored as x minus 5. So a minus equals, just say take x, subtract 5, store it back into x. It's a nice shorthand notation that a lot of programming languages use. Once you do that, if you were to log it out, it would show 15 because 20 minus 5 stored back into x, well, x is now going to be 15. The multiply equals is the same idea. Take whatever y is, multiply it by 2, and store it back into y. So if y was 50, 50 times 2 should be 100. Same idea with divide equals. 8 divided by 2 is 4. Store it back into z, print it out. So the first one, use the plus equals mathematical assignment operator to increase the value stored in level up by 5. How do we do it? Let's look at level up. We want to plus equals it, and we want to go up by 5. So all we need to do is level up, and we're going to plus equals 5. Once you run that, you'll now see level up is no longer 10, but instead 15. Makes sense? Same idea, minus equals. Let's take the power level and decrease it by 100. Power level minus equals 100. Now we're down to 8901. Multiply me. Star equals 11. All we're doing is now multiplying something by 11, storing it back into multiply me. And quarter me. To divide by 4, divide by equals.
Since we can't hear you.
Can you guys hear me now? Testing, testing, 1, 2, 3. Hello, hello, hello. Let's go ahead and call it here. We've got 5 minutes left in the class. I'm going to leave the remaining exercise as homework to go and complete this. I think you're seeing that this is not too hard. We're getting closer though. Once you guys have gone through some of these examples, we can then take some of these and actually start to apply that to Ethereum blockchain, meaning that we should be able to take the Web3 plugin that we're working with metamask and actually call some of the methods properties, store them into variables, and interact with the blockchain. So we're building up to that. I hope you guys can see it happening. It is a bit perhaps tedious at first, as most programming.
Hello, Ben.
You got any
Sorry,
questions?
since we can't hear you.
Really?
Since something is wrong with the audio.
Interesting. It may be a bad internet connection. Testing, testing. I hear you guys fine. Is everybody else having issues? Somebody raise their hand. I see Ken. Alex says, we can't hear anything. Okay. Well, I can try switching different VPN. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Is this any better? Hello, hello, hello. Testing, testing, 1, 2, 3. Is that any better? I'm going to assume so. I see that the microphone in Zoom is showing that my audio is working. So I hope it is. Okay, I think we're coming up to the end of the class, either by force or by choice. Are there any questions that have come about? I'll try to answer them now. Lost your audio. Audio seems to be off. Yes, yes, yes. Same. No sound, no sound, no sound. Okay. I apologize for the audio situation. I don't know. I'll try to turn it off, the VPN. Testing, testing. Is this any better? Has my voice come back? Hello? The joys of internet. Okay. I think we're going to call it here. Apologize for the audio issues. But if there are any other questions, let's go ahead and switch on over to the group chat, and I will take more questions out there and we can answer from there. Apologies, guys, for the disruption. Okay.